Mr. Saju SR. Saju is Head of Product and Process Engineering of Smart Power Division of Electrification Business in ABB India, managing Make in India initiatives, Industry 4.0 and 5.0, and life cycle management. With an industry experience of over 2 decades, Mr. Saju is instrumental in digitalizing the smart power factory and implementing Industry 4.0 and 5.0 technologies, making it one of the benchmark units. Coming with an engineering background, he is MBA in Operation Research. Under his initiative, Smart Power India has won gold for manufacturing excellence and second runner-up for Smart Factory of the Year award from Frost Sullivan in the IMEA Awards 2022. Mr. Saju has played a vital role in making the unit more Atmanirbhar by increasing the local content in the products. He is also a member of Industry 4.0 Expert Committee, Bangalore, Chamber of Industry and Commerce. Today, Mr. Saju SR will give us brief view of taking shape with Industry 4.0. Manufacturing is advancing towards Industry 5.0 ESG. So delegates, let's welcome Mr. Saju SR.
So today I'll discuss in two parts exactly what is Industry 4.0, 5.0, as well as what we had done in our factory related to the industrial revolution. So before we start, let us have a refresher of what exactly is Industry 4.0 or 5.0, because there are a lot of misconceptions and this is an overused term, 4.0 and 5.0, many times out of context. So just to give a clarity on what we are discussing, let me start with a refresher for all of you on exactly what these are. So Industry 4.0 is basically the fourth industrial revolution. So before going into it, we will discuss about what the other industrial revolutions were. So it started in the 1700s, late 1700s, where with the usage of steam engine to reduce human effort in production systems. That was the first industrial revolution. The second one happened in the late 1800s, where electricity was used for production, and the concept of mass production also came into picture, so increasing the industrial output. And in the second half of 1900s, the automation came into picture. So that was a big change or a huge change, and that is actually what is defining the Industry 4.0 or even 5.0. So here we talk about automation and usage of digital tools to a little bit. So when we say automation, we mean usage of industrial robots also started then the usage of SCADA, PLCs, and for the first time ever, we started using the desktops for production. That means the usage of computers also started. So it started becoming digital in Industry 3.0. So Industry 4.0 is a build up on 3.0. So that is where normally the confusion lies. In fact, if you ask me, automation is not Industry 4.0. Automation is Industry 3.0. So then what is the difference between Industry 3.0 and 4.0? So in 4.0, we talk about connecting the OT to the IT. OT means the operation technology, which is our MESs and MOMs, and IT is the information technology. So this is done through IoTs. Earlier, the information remained in the factories only. Now we can access it through the internet. So that is a major change which happened in Industry 4.0. So the major platform being the usage of cloud computing, the big data coming into picture, and interconnection of the processes. Earlier, the processes were a little bit working in silos. There was no communication between the processes also. So Industry 4.0 bridged that. And why the name 4.0 came into picture. So in the year 2016, there was a book released by Mr. Klaus Schwab, who is the founder chairman of World Economic Forum, called The Fourth Industrial Revolution, where he talks about cyber physical systems. So that's the point. So it's a cyber physical system. Earlier, it used to be only physical system. So Industry 5.0 talks about man-machine collaboration, where we only talk about automation or digital, but the human touch is also coming. So why can't man and machine work together in close proximity? So even though we talk about automation in Industry 4.0 and 3.0, so there were machines were separated and humans were separated. So that's a major one. So what was the purpose of ABB getting into Industry 4.0 or smart manufacturing? So basically to make the operations more safe and sustainable, because the electrification, we say our purpose is to provide safe, smart, sustainable electrification to all. So our operations also needs to be safe and sustainable, and the operations has to be smarter. That means the chances of error or the system is controlling the output or the process rather than any human intervention happening here. And we had enough experience in Industry 3.0 so that we can move up to Industry 4.0 also. But what was the need? In fact, so this is there are a lot of challenges faced by the industry, like operational, logistical, and many are there. So I would focus on the operational challenges here. So first of all, there is a lack of data for decision making, because many times, even though we had a data, the quality was not that good. Then the delayed information, for example, there is a breakdown in the line, so the information is going to the people delayed, leading to high downtimes, and high downtime itself due to other reasons also is an issue. Then there is no integration within the value chain. For example, there's a production floor and a store. Many times what is happening in the production floor is not aware to the store guy, and many times we see that the material availability all are affected and there are disconnections, and the quality is inconsistent because the processes are also not consistent. Many times the quality of the output depends on the human who is working here. So that takes me to the next point, the skilled manpower. So nowadays that's a big challenge. People are moving around, so getting skilled manpower is one of the biggest challenges faced by the industry. Then whenever we want to increase the production or bring in new products, there is a big need of products. So there is no flexibility in the production line, so which is leading to these issues. Then because of all these inconsistency or lack of skilled manpower, there are a lot of reworks happening, increasing the energy consumptions also, and this process are not sustainable because we are over processing many times, and sometimes the operations are a little bit critical, reducing the safety in the operations. So these were the needs. So what we did, the main focus area or the key results areas, what we focused upon was basically the industry 4.0 initiatives, like interconnecting the processes using IoT devices to take in the data from any part of the world. Then the industry 5.0 initiative, we have our own cobots. ABB manufacture cobots. IMEA is one of the best cobots available today. So we are using the cobots, and this is a real photo from our factory only. Then we did automation. The idea of selecting a process for automation is the safety level. Then there are some operations which machines can do more efficiently than human being, like lifting and working in little bit warm conditions where humans are not too recommended to do that. And there are some non-value adding activities, for example, assembling a screw. So one operator doing screw assembly for entire 8 hours or 9 hours doesn't make any sense. So those kind of things we automated. Then Kanban we implemented. Along with it, we implemented electronic Kanban, so that the Kanban system is connected to the production line according to the consumption happening in the production line. So the Kanban replenishment happens. Then we also implemented the mobile industrial robot. This is more like an industry 5.0 initiative. So we spoke about industrial robots, which are normally of the fixed type. So then we moved to the mobile industrial robot, which is moving the finished goods from the production area to the dispatch area. That was another problem which we are facing, that products were not moving to the dispatch area on time, affecting our on-time deliveries. Then lastly, we were using our own solutions. We had a lot of automation solutions which we are using. Then converting the lines, rebalancing all the lines into tact lines, and this tact time is controlled by the system itself. The operator cannot produce earlier than the tact time or after the tact time, and every tact is being measured also by the system. Then we had a lot of inspections which were happening by a different team, like the quality teams comes and do the pre-dispatch inspections and all. So we removed everything, and the inspections are done either by a system or the people who are working in the line itself are taking care of the quality. So that reduced a lot of wasted time. Then productivity increased definitely. When we do all these initiatives, productivity will definitely improve, which improves further on the on-time delivery. And because of making the processes more consistent, the quality of the output also was very good. And 5S, when an organized factory normally gives a pleasant atmosphere for people to perform better, making the outcome also very good. So these were the major areas. Some of the unique features we did is, for example, the operations are connected end to end. It is not like, for example, if you are in a manufacturing line, the processes are connected right from the first station to the packing station to the dispatch area. For example, we launched the order in the smart factory. The entire production quality is taken care by the factory, and movement of the material also to the dispatch area, as I mentioned earlier, is also taken by the industrial robot. And to reduce the space, we combine many test areas into one. For example, we have 3 different process lines or process families. Then we can have a common test cell rather than having 3 different test cells. So this helped us reduce the production area by a large extent. Maybe I would say that about 30% space we could reduce by combining the processes. Then as an industry 5.0, we have the collaborative robots, and we have a concept of ABB products, manufacturing ABB products. So we already have 21 robots and more to come, to also getting assembled here now. And the another one is because of work from home, many people could not come to office. So we were facing a lot of challenges in controlling the processes. So we have the option of controlling remote accessing the process lines and controlling the parameters from the home itself. Then, as I mentioned earlier, the delayed information is the biggest problem. To avoid that, we have auto email systems. In case of a breakdown or calibration is due, the mail or information goes to the concerned people so that they can take actions on time. Then auto data capturing, and this brings in, and this is available online. So the data transparency is also very high. It is not staying with anybody. So anybody who is authorized can see the information. And the auto MIS also helps in people. Earlier, people were only preparing data. About 30% of their time was going in collecting the information and presenting it in a format way. Now the computer is doing it so that people can focus on the actions rather than data collection. And then again, we have a family of robots, all kind of robots working together in the factory. And some of the key features which we could achieve is, traditionally we talk about batch size or batch production or mass production. Now the new concept is lot size 1. So we can have every product different in the line because the systems are taking care of it. We have a unique barcode on every product. The scanning happens and the system changes the parameters according to the product which has come, and no manual intervention required. So lot wise size 1. This is very much important for the people who do assemble to order items. So we also have some products which we do that way. So that is helping us. Then the work instructions are interactive, so that every time you do an operation, you need to access to acknowledge that I have done the operation. Then only the system will let you process the next one. Then WAP control, tag control, everything is done by the system. You can't have more WAPs. Systems will not let you produce. And in case of TACT also, before the TACT time is over, you can't produce. And all the processes are interconnected, ensuring that, for example, station 2 checks with the station 1 whether all the processes has been completed or not. Then process tracking is there because all the information is there. And operator, every operator has to scan his ID card, so that we know who has made it. In case of any discrepancy in the product we find later on, we can train the operator. And the skill metrics of the operators are generated by the system itself, by the amount of time he spends there, the quality of the work, and the quality of the output. And data is of high quality. There is, because it's always captured in the same way. So there is no intervention, so it is very high quality. And the data can be drilled down to any level, starting from the factory to a product line, to a variant, to a process line, to anywhere. And we have electronic gambas rather than the conventional gambas where we normally used to take papers and then present it. So you can go to the system, open and see what has happened. And usually we talk about reactive quality, then we come about the preventive quality. Now we talk about predictive quality. So there are sensors and systems which will tell that your CPCPK values are going above the limit, or there's a trend in the processing. So you can adjust the systems. So some snapshots of some of the softwares we are using is an ABB Ability Energy Manager, which we use, which keeps a track on how much energy we are consuming. And in case of there is any abnormality, there is an option that the system will send an information to you so that you can take action on time. And smart sensors, these are the sensors which we use on our motors. So this checks the vibration and abnormal noise of the machines, so that in case of any abnormality, it will tell you that this equipment is going to fail by within this time. So this is kind of a predictive maintenance. So you can plan so that there is no downtimes in the line. Then we have robots. Whenever there is any error in the robot, it will again send an alarm to us, so that we don't need to wait for it to fail. And another one is our own building management system, where it is controlling the entire energy management also. So our data says that after implementing this building management system and the lighting management system, the energy consumption has reduced by 20% because all the wastages has been controlled by the system. All the air conditioning, the lighting, everything, HVACs are controlled by the system rather than any human being. So the evolution. So this is how we evolved. We started working on smart manufacturing in 2017. In 18, we launched the first smart factory. Then in 2019, we upgraded with higher quality interactive SOPs and more data quality. Then last year, we completed the version 3 with collaborative robots, mobile industrial robots, and remote access option during work from homes and data drill down. And we have a 165-inch Andon board also in the factory, which will show the data live. And next year, we are working on AI, the AR/VR, the predictive maintenances, the cloud computing, because as a policy, we are removing all on-prem servers and moving to cloud. then mobile apps, the warehouse management system also we'll be implementing in the next 2 years, so that we have end-to-end connectivity in all the process. So that's what we achieved. So now today, if you see, we are future ready. We are already in industry 5.0. We have stepped into industry 5.0 systems. So our operations are safe because there is no hazardous activity performed by anyone, and it's a smart factory because the factory controls the output rather than the operator doing having too much control on making any mistakes. And anyway, as the systems become more efficient, so we are more sustainable, and there is a coexistence of man, machine, and milieu, which is the environment. So that's all what I had to present today. Thank you.